In this example, we need to verify by substitution that the given function y equal to cosine of 3x, right? So this function is actually the solution of this differential equation, where this prime denote the derivatives with respect to x. So how do we show that this given function y equal to cosine of 3x is the solution of this differential equation? What we are just going to do is substitution. So we are just going to substitute this function into this given differential equation. But to substitute, if you look into the differential equation, there are two terms you can look into it. One is y double prime and another is 9y, where I can substitute y directly over here, right? But if I want to substitute for y double prime, I need to find that. So why don't we do that first? So first figure out what is y double prime. Okay, so how do you find y double prime? Y double prime means the second order derivative of the given function, right? So if that is the case, we are first going to find the first order derivative. That means we first find y prime. So how do you find y prime from cosine 3x? We know the derivative of cosine x is negative sine x, right? So this is the derivative of the cosine x. But here the cosine function composed with 3x. So if that is the case, we need to know what is the derivative of cosine function composed with some other function of x. Let's say g of x. We are going to use here, if you have a composite function, to find the derivative of that, we are going to use chain rule, right? So the derivative of cosine of gx is, derivative of the cosine is negative sine, like the previous formula over here, right? So negative sine. But since we have now some function composed, instead of x we'll have this negative sign composed with that function g of x. But also, since this is composite by the chain rule, we need to multiply by derivative of this g of x with respect to x, which let's say g prime of x. So this is kind of your formula to find the derivative of cosine of 3x. So if we apply this formula here, derivative of the cosine would be negative sine. We compose that with 3x, right? So like over here this function, but also don't forget to multiply by derivative of 3x with respect to x, which is 3. Okay, so we get then y prime as negative 3 times sine of 3x. This is our y prime, but our goal is to figure out what is y double prime. So let's do one more derivative, but the similar process, right? So this is negative 3 multiply with cosine of 3x. So we are going to use what rule? Constant multiple rule, which is write down the constant as it is. So let's write down negative 3, but now find the derivative of sine of 3x. So again, to find the derivative of sine of 3x, we need to know derivative of what? Sine function composed with something. So we know derivative of the sine is cosine x, fine. But here sine function composed with 3x, so we need to know this formula, which is when the sine function composed with something else, let's say g of x. The formula is derivative of the sine is cosine, compose that with g of x, but now don't forget to multiply by the derivative of g with respect to x, which is g prime of x. So utilizing this formula, our derivative would be, derivative of the sine would be cosine, compose that with 3x, but don't forget to now multiply by derivative of 3x with respect to x, which is 3. So altogether we have negative 9 cosine of 3x is the derivative of second order derivative of cosine of 3x, right? So we needed two things. One is y double prime, so which is here, right? We needed y, which is given. We can just substitute this back here to the equation. When we do that, I hope we'll be able to verify that the given function, either that is the solution of the differential equation or not. Okay, so let's do that. Okay, so we have y double prime plus 9y is equal to 0, right? So we figured out y prime here, right? So this is our y double prime. Substitute that here. So when you substitute that, we get negative 9 cosine of 3x, so this is our y double prime. Now we have plus sign, and then plus 9 times y, so we'll have 9 times y is given as cosine 3x. We substitute that. This has to be equal to 0. So let's try to see if that is the case or not. Well, this is a straightforward look, right? So when the first term is negative cosine of 3x, the second term is 9 times cosine of 3x, which is obviously 0. So we clearly verify that this function given over here is actually the solution of this differential equation. So we may want to write maybe verified.